Hello everyone, I'm Divya here, Department of Chemistry, ASC Independent PU College. Hope all of you all are safe and healthy. And it is social responsibility of each and every one of us to keep ourselves safe and also to educate others to be safe from this deadly coronavirus. Okay, today I welcome you all for online chemistry classes and discuss about the chapter General Principles and Process of Isolation of Elements. This is one of the easiest, simpler and an interesting chapter, fetching you 4 marks in your theory examination. One 1-marker question and one 3-marker question can be expected from this chapter. Isolation of elements or extraction of metals. I think now you people are familiar with the topic of extraction of metal, which you've already studied in the earlier classes under the name of the chapter Metallurgy. Yes, in this chapter we are going to study about extraction of metals from their respective ores. Now students, I kindly request you all to check the video again for better understanding of the chapter. The basic terms to be known are ore, metallurgy, gangue. Ore, the minerals from which the metals can be extracted economically are called ores. Remember, all ores are minerals, but all minerals are not ores. I repeat again, all ores are minerals, but all minerals are not ores. Example, minerals of iron are ferric oxide, ferroferric oxide, iron sulfide, iron carbonates. Similarly, aluminium occur in nature as bauxite and clay. Metallurgy, the entire scientific and technological process used for isolation of metal from its ore is known as metallurgy. In simple, the process of extraction of metal from its respective ore economically is called metallurgy. Gangue, the earthy impurities like clay, sand, mud, rocky matters associated with ore is termed as gangue or matrix. Mineral, naturally occurring chemical substance present in earth crust, which is obtained by mining, are called minerals. They usually occur as oxides, carbonates, chlorides, nitrates, phosphates, sulfides, silicates, etc. Minerals like gold, silver, platinum occur in the native form in the nature due to their low chemical reactivity. Now, what do you mean by the term native form or combined form? Native form or free state or metallic state mean elements which are not attacked by moisture, oxygen and carbon dioxide occur in native state. Example, carbon, sulfur, gold, platinum, noble gases, etc. Combined state, elements which are readily attacked by moisture, oxygen, carbon dioxide occur in combined state in the form of compounds called minerals. Usually they are found as halides, oxides, nitrites, sulfides, carbonates. Here you can see the list of some of the ores of the respective metal. Bauxite, kyanite are the ores of aluminium, hematite, magnetite, siderite, iron pyrites are the ore of iron, and its respective composition is given in the table here. Ores of copper are copper pyrites, copper glands, malachite, cuprite, and ores of zinc are zinc blende, calamine, zincite. Pyrolusite, braunite are the ores of manganese. Limestone and gypsum are ores of calcium. Cinnabar is the ore of mercury. And now you can see the picture of some of the ore. This is magnetite. the ore of iron. Hematite, ore of iron again. Galena, ore of lead. Zinc blende, the ore of zinc, can be seen in this picture. Limestone, that is the ore of calcium, is seen in this picture. Okay, now let us study the process involved in extraction of metals. The process which are involved in the extraction of metals are crushing and grinding of ore, concentration or dressing of ore or benefaction of ore, isolation of metal from its concentrated ore, and last, purification or refining of metal. These are the 4 steps involved in the process of extraction of metals from its respective ore. The first one is crushing and grinding of ore. Usually, the ore occur as huge lumps in the nature. Now, they are broken down into smaller pieces with the help of crushers or grinders, and these pieces later reduced to fine powder with the help of ball mill or stamp mill. This process is also called as pulverization. So basically, in the first step of extraction, the huge lump of ore is being converted into fine powder by crushing and grinding. The second step is concentration or dressing of ore or benefaction of ore. This method involves different processes. First, gravity separation, levitation or hydraulic washing, magnetic separation, froth flotation, and leaching are the different methods involved in the concentration process of ore. The first is gravity separation or levitation or hydraulic washing, also called as hydraulic classifiers. The principle behind this process is lighter earthy particles or impurity are removed from the heavier ore particles by washing with ore. That is the difference in specific gravity of ore and gangue. Now in this process, the powdered ore is being taken at the top of Wilfly table and washed with the stream of running water. The lighter gangue particles, that is impurity being lighter, is being washed away, whereas ore particles being heavier settles down. This method is generally used for concentration of oxide ores like iron ore, chromite ore, tin ore, native metals like gold, silver, etc. are concentrated by this hydraulic washing. Next method is magnetic separation. In this method of magnetic separation, you can see 2 rollers, one being magnetic in nature, the other being non-magnetic in nature. The basic principle behind this ore is, that is, the ore particles being magnet in nature can be easily separated from the impurity which is being non-magnetic in nature. That is, ore particles being magnetic in nature and impurities being non-magnetic in nature. In this method, the powdered ore is dropped over the conveyor belt, moving around the 2 rollers, one of which has electromagnet in it while the other is non-electromagnet. As the ore particles roll over the belt, the magnetic particles are attracted by magnetic rollers, as a result of which you can see it forms a heap, 2 heaps separately over here. The heap collected below the magnetic rollers the heap which is collected below the magnetic rollers contains magnetic particles, while the heap formed away from the magnetic rollers, that is, this heap which is formed away from the magnetic rollers, contains non-magnetic impurities. For example, if you want to separate tin stone, which is non-magnetic in nature, and tungstate, which is magnetic in nature, you can just pass on these ore particles over the conveyor belt with two magnetic rollers, one being a magnetic roller, the other being non-magnetic. Once the powdered ore passes over a magnetic roller, the magnetic particles, that is tungstate, are attracted and forms a heap over here, whereas tin stone, being non-magnetic in nature, form separate heap. Similarly, if ore particles are magnetic in nature and impurities being non-magnetic in nature, both forms a separate heap and are collected separately. This is how the magnetic ores, that is ores being magnetic in nature, are being separated by this process. And you can see, and this is a kind of magnetic rollers, and this is how the magnetic roller look like. Froth flotation process. This method is specially applicable for concentration of sulfide ores like zinc blende, copper pyrites, galena, etc. This method is based on the principle that the surface of sulfide ores are preferentially wetted by oil, while that of gangue particles are preferentially wetted by water. I repeat, that is, ore particles is being wetted by oil, while that of gangue particles is being wetted by water. First, the ore is crushed into fine powder and mixed with sufficient water to form suspension in the tank. To this suspension, we are going to add collectors like pine oil, fatty acid, xanthates, that is ethyl xanthate and potassium ethyl xanthate are added. Now, what is the use of addition of these collectors? These collectors enhances the non-wettability of ore particles. Stabilizers like cresols and aniline are added to stabilize the froth which is formed. I repeat, collectors are added to enhances the non-wettability of ore particles. Stabilizers are added to stabilize the froth. Now, the suspension is violently agitated by rotating the paddle wheel. Here in the figure you can see that once this paddle wheel is rotated violently, it draws the air into the tank, resulting in the formation of froth. During this process, the ore particles which are preferentially wetted by oil becomes lighter and rises to the surface along with the froth. That is, the ore particles are present along with the froth, whereas gangue particles which are combined with water becomes heavier and settle down. That is, the impurity which combines with water becomes heavier and settle at the bottom of the tank. Now, the froth which is containing the ore particles is being skimmed off and it is treated with suitable organic reagent, and it is washed with water and finally dried to get the concentrated ore. This is how the sulfide ores are being concentrated. Now, in this figure you can see the froth formed at the surface. It is important to remember collectors are added to enhance the non-wettability of ore particles. Stabilizers are added to stabilize the froth. Now, in case the ore particles to be concentrated contains two metal sulfide ores. Example, if the ore to be concentrated consists of two metals, let's say zinc sulfide and lead sulfide. Now, this can be separated by adjusting the proportion of oil to water or by adding suitable depressant. Now, to separate the mixture of zinc sulfide and lead sulfide, the suitable depressant is sodium cyanide. Once this sodium cyanide is added, it immediately forms a complex with zinc. That is, it forms sodium tetracyanozincate. A complex is formed. And this formation of complex prevents the formation of froth. During this condition, only lead sulfide forms froth, and hence it can be easily separated from zinc sulfide. This is how zinc sulfide and lead sulfide ores can be easily separated by concentration process. The last method in concentration of ore is leaching. In this process, the powdered ore is being treated with suitable reagent such as acids, bases, or other chemical substance, which can selectively dissolve only the ore but not impurities. That is, ore when dissolved with suitable chemical reagent or solvent dissolves, whereas impurities are left behind as residue. This process of leaching is better explained by considering bauxite ore as an example. The process of leaching bauxite ore is called Bayer's process. At the end of the process, we obtain pure alumina. The bauxite ore usually contains impurities of iron, silica, and titanium oxide. The powdered ore is heated with concentrated solution of NaOH about 45% at a temperature of 473 to 523 Kelvin. I repeat the temperature 473 to 523 Kelvin and a pressure of 35 to 36 bar. In this process, the bauxite ore, once dissolved in the sodium hydroxide solution, forms a complex of sodium aluminate. This is the complex of sodium aluminate. The silica which was present combines with the sodium hydroxide, forming sodium silicate. Now the above mixture is subjected to filtration. So, the impurities get separated easily by filtration. Now the filtrate contains sodium aluminate and sodium silicate, and also with some amount of NaOH which is unused. The next step, this solution, the above solution, is neutralized with carbon dioxide and seeded with pure alumina. After seeding with pure alumina and neutralizing with carbon dioxide, we get hydrated alumina along with sodium silicate which is present. Again, this mixture is being filtered. After filtration, the sodium silicate remains in the solution. The hydrated alumina which is obtained here is now heated to a temperature of 1470 Kelvin and it is being dried to get the pure alumina. This is how the pure alumina is obtained by leaching. Remember, here the seeding agent of pure alumina is added. The seeding agent enhances the precipitation or formation of precipitation and hence hydrated alumina precipitate out. Ores like silver and gold are being concentrated by this method of leaching. First, the ore containing silver or gold is treated with dilute solution of about 0.5% of sodium cyanide or potassium cyanide in presence of atmospheric air or oxygen. Now, the silver and gold get oxidized and then combines with this cyanide ion, forming a soluble complex of metal cyanide along with some insoluble impurities. It is being filtered. During filtration, the impurities are filtered off and the solution contains a complex of metal. In order to recover metal, this is being treated with an highly electropositive metals. This electropositive metal displaces the metal over here present in the complex. Here you can see zinc metal being highly electropositive in nature displaces the metal which is present in the complex, and this is how the metal is being recovered. With this, we have studied the different methods employed in concentration of ore. That is, we have studied about hydraulic washing, magnetic separation, froth flotation, as well as leaching. The examiner's favorite over here is leaching of bauxite ore. That is, you can expect the question from the bauxite ore, that is leaching of bauxite ore, for 3 marks, and also the question from froth flotation can be always expected for 1 mark. The next process in this extraction of metal is isolation of metal from concentrated ore. This actually depends on the nature of the ore as well as on the nature of the impurities present along with the ore. This involves 2 major steps. One is conversion of concentrated ore to its oxide form called oxidation, and conversion of oxide to metal, that is reduction. I repeat, first step, conversion of concentrated ore into oxide form, and later reduction of this oxide to metal. First is conversion of concentrated ore to oxide form called oxidation. In this process, the ore which is in the form of the concentrated ore which is in the form of hydrated oxide, carbonate or sulfide can be easily converted to its oxide by these 2 methods, that is calcination and roasting. First, calcination. It is a process of heating the concentrated ore strongly in limited supply of air or in absence of air. I repeat, calcination is carried out in limited supply of air or absence of air. During this process of calcination, the carbonate ore gets decomposed to form oxides of metal. Example, you can see over here in the reaction, that is zinc carbonate easily decomposes to zinc oxide, and carbonate ores of calcium carbonate, magnesium carbonate also easily decomposed to calcium oxide and magnesium oxide respectively by liberating carbon dioxide. The water of crystallization present in the hydrated oxide ore, like hydrated ferric oxide, loses its moisture or water molecule when subjected to calcination. During this process of calcination, even if organic matter is present, get easily expelled off, and the volatile impurities can be removed very easily, and now the ore becomes porous. This method of calcination is specially applicable for carbonate ores. Next method is roasting. Roasting is done for sulfide ores. It is a process of heating the concentrated ore strongly in excess of air or oxygen below its melting point. For example, sulfide ores like zinc sulfide, lead sulfide, copper sulfides, when it is treated with excess of oxygen, it forms respective oxides of zinc oxide, lead oxide, copper oxide, liberating this sulfur dioxide gas. This sulfur dioxide gas liberated is actually utilized in the manufacture of sulfuric acid. During this process of roasting, the volatile impurities are easily expelled and the ore becomes porous. Even after calcination and roasting, still some non-fusible impurities of earthy matters remains along with the ore. In order to get rid of this, or in order to remove this, the additional substance called flux is usually added during the process of reduction. Flux, Flux, is a substance that chemically combines with gangue to convert non-fusible substance into fusible material known as slag. Flux plus impurity or gangue forms slag. The slag, which is formed at lower temperature of the furnace, melts easily and it is immiscible with the metal. Even at lower temperature, having lower temperature and lower melting point and density, the slag starts floating on the surface of the metal. It is removed from the furnace through slag holes, or it can be skimmed off very regularly. Types of fluxes. Depending upon the nature of impurities present in the ore, flux are being classified into two types. One is acidic flux, the other one is basic flux. Acidic flux is used to remove basic impurities and basic flux is used to remove acidic impurities. I repeat, acidic flux are used to remove basic impurities and basic flux are used to remove acidic impurities. Acidic flux like silica, borax, etc. are used to remove the basic impurities like lime or metallic oxides like calcium oxide, iron oxide, manganese oxide, etc. Basic flux. It is used to remove the acidic impurities like silica oxide and phosphorus pentoxide present in the ore. Example of basic flux are calcium oxide, magnesium oxide and iron oxide, etc. The slag which is formed is usually silicates. In this video, we have studied about concentration of ore as well as isolation of concentrated ore. In this, we have first studied about conversion of concentrated ore into its oxide form. In the next video, we are going to study about reduction of this metal oxide to metal. Thank you. Before I conclude with this video, I request all students to go through the video again for better understanding of the concepts in the chapter here. Stay at home, stay safe, and keep learning chemistry.